This is 2020 AMC 10A, problem number 18. Let A, B, C, D be an ordered quadruple of not necessarily distinct integers, each one of them in the set 0, 1, 2, 3. For how many such quadruples is it true that A times B minus B times C, A times D minus B times C is odd? For example, 0, 3, 1, 1 is one such quadruple because 0 times 1 minus 3 times 1 equals minus 3 is odd. A, 48, B, 64, C, 96, D, 128, and E, 192. So we want this value here to be odd. So we want AD minus BC is odd. So there are two ways for this to happen. AD is even and BC is odd, or AD is odd and BC is even. But we can quickly realize that these two cases are symmetric to each other. So we can just calculate one of the cases and then multiply by 2 to get the value of the other. So let's say that we choose this case here, the first case. So AD is even. All right, so for AD to be even, there are two cases. Case 1 is that A is even. So let's say A is even. So there are two choices for A, and then there are 4 choices for D, because D can be anything, because if one of them is even, the other doesn't have to be even. And then case 2, I should specify this. This is AD is even. And then case 2 is that AD is odd. So once again, 2 possibilities for case 2 is that A is odd. So there are 2 possibilities for A to be odd, 1 and 3. So then D has to be even, so 0 or 2. So there are 2 possibilities here as well. So this equals 6, and this equals 8, not 6. This equals 8, and this equals 4. So this gives us a total of 12 here. And then we also want BC to be even. BC is odd. So BC is odd. And for BC to be odd, they just both have to be odd. So this is simply 2 times 2, because 1 and 3 are the only odd numbers. So this equals 4. And since we want both of these events to happen simultaneously, it's an and, it's not an or. So it's not an or, it's an and. We have to multiply them together. So we have 12 times 4. And since we applied symmetry, we have to account for the other case by multiplying by 2, and this will give us 96, or an answer choice of C.